In this video, we will learn how to find out the competitive equilibrium in an exchange economy. The question is, there are two goods X and Y and there are two consumers A and B in a pure exchange economy. A and B have the Cobb-Douglas utility function of form UA is equal to 2x raised power 0.4 times y raised power 0.6 and utility function of consumer B is equal to x raised power 0.3 times y raised power 0.7 respectively. Initially, consumer A is endowed with 50 units of good X and 20 units of good Y. Similarly, consumer B is endowed with 50 units of good X and 20 units of good Y. If unit price of good Y is normalized to 1, then the equilibrium unit price of good X we need to find out. Okay. What we are being given? We are being given the utility function for good A. Okay. In place of X and Y, I have given them the subscript says A and A here to differentiate it with consumer B. Okay, that means the utility function of person A is being given us as this and utility function of person B is being given us as this. Okay, now first we need to find out, first step will be to find out the initial endowments of each consumer. Here WAX means the units of good X endowed by person A, and we are being told that person A is endowed with 50 units of good X, so WAX is 50. Similarly, WAY means units of good Y endowed by person A, and we are being told he is endowed with 20 units of Y. Okay, so WAX is this stuff, WAY is this stuff. Similarly, for consumer B is endowed with 50 units of good X and 20 units of good Y. Here you can see. Third step will be to construct, rather to find out the income of the consumer. In this case, total income of the consumer is only the initial endowments that the consumers have. Okay, so what will be the income of consumer A? That will be equal to price of X times endowment of good X plus price of Y times endowment of good Y held by person A. Okay, and we are being told WAX is 50, so in place of this we write 50 px. Since price of x is normalized to 1, so py is 1, and endowment of a good Y held by person A is 20, so we get here income of the consumer is 50 times px plus 20. Okay, symmetrically the income of the consumer B will be equal to price of X times units of X held by B plus price of Y times units of Y held by B. That is, units of good X held by B is 50 times price of X plus price of Y is normalized to 1, so 1 into the endowment of good Y held by B, which is 20. So these are the income of the consumer. Then next step is obviously to find out the total supply of good X. Now what will be the total supply of good X in this economy? So supply comes from the initial endowment of person A and B. Now for good X, total supply will be equal to the endowment of person the endowment of person A plus the endowment of person B. Okay, that is the units of X held by person A initially plus the units of X held by person B initially. So we have WAX is 50, WBX is 50, so 50 plus 50 is 100. 100 is the total supply in this economy for good A. What is the demand for good X? So total demand for good X will be equal to the demand of good X by person A plus the demand of good X by person B, and it will be equal to 2 upon 5 MA upon PX plus 3 MB upon 10 PX. If you are wondering how did I calculate it, it is very simple, and let me explain it here how you find out the demand. I will not do, it's up to you. I will only give you an idea how do I got XA is equal to this stuff. What you need to do, since we have to find out the demand function of good X by person A, we want to maximize the utility of person A. That is, the utility function of person A is given as twice x raised power 0.4 y raised power 0.6 such that price of X times units of X plus price of Y times units of Y in 11 it should be equal to the income of the consumer A. Okay, you want to solve this maximization problem, and when you solve it, what you will get, you will first equate marginal utility or MRS should be equal to price of X upon price of Y. That is the marginal utility of good 1 upon marginal utility of good X, marginal utility of good Y should be equal to price of X upon price of Y. Okay, then you will solve it further. So marginal utility of good X, when you solve, then so marginal utility of good X means the partial derivative of utility function with respect to X divided by marginal utility of good, the partial derivative of utility function with respect to Y, and you equate it with price of X upon price of Y, and when you solve it, you will get the demand function for good A, and for demand for good X by consumer A is this, and similarly for XB you need to solve another demand function, that is you want to maximize utility of consumer B, which is equal to X raised power 0.3 Y raised power 0.7 such that price of X times units of X plus price of Y times units of Y should be equal to the income of the consumer B. Okay, solving this condition, you will get demand function for good X for B. Okay, so you will get this very stuff. At equilibrium, we know that demand for good X will be equal to supply of good X. Okay, so demand for good X is this 2 upon 5 MA upon PX plus 3 MB divided by 10 PX. This is the demand, and the 100 denotes the supply. Making denominator same, multiplying numerator and denominator with 2. So denominator is same, we can add the numerator. So it becomes 2 into 2 is 4 MA plus 3 MB upon 10 PX is equal to 100. Okay, so 4 times what is the income of the consumer, that is this very stuff 50 PX plus 20 plus we have 3 here, MB is the income of the consumer B, which is 50 times PX plus 20 and divided by 10 PX is equal to 100. Okay, doing multiplication, 4 into 50 is 200 PX plus 4 into 20 is 80 plus 3 into 50 is 150 PX plus 3 into 20 is 60 upon 10 PX should be equal to 100, which comes out to be, so 200 PX plus 150 PX sums up to 350 PX plus adding 80 and 60 sums up to 140 divided by 100 PX. Then transposing this here, it will get multiplied, so we have 350 PX plus 140 is equal to 1000, because 100 into 10 is 1000 PX. Transposing this 350 here, it will get subtracted, so 1000 PX minus 3 PX comes out to be 140. Subtracting 350 from 1000, it comes out to be 650 PX, which is equal to 140, or PX will be equal to 140. Transposing 650, it will get divided, so we will get 14 upon 65. Price of X will be equal to 14 upon 65, and you can convert it into the decimals also. Okay, I hope I make myself clear in this video. Thank you.